conservation of energy says that when I go through a closed loop, okay, what I'm doing is, if you like, I have a closed loop, I start at some height, I gain energy, and then I go through the circuit, and that energy is used up. So it's as though I started at some height, I went through a hill, a bumpy hill, lost all my potential energy, came back. I want to go back to my starting point, so my battery pumps me up back there. I again gain energy, go through, lose that energy, and it repeats. So what you're saying is, at any point on the circuit, you can specify how much energy you have. But remember, we said that the wires are not using up energy. So it means I gain energy E. If the circuit is closed, I have to lose that same energy across the resistor. That is to say, the total change of energy when I go and come, remember, I'm keeping track of potential energy. I'm not keeping track of the heat energy that's going away from the circuit. So if I were doing it under gravity, I'd have some potential energy, I'd lose it, I'd come back to this point. When I return to the same point, I have the same amount of energy, potential energy again. So the total change in energy as I go around the loop is 0. So how do I write this in case of circuits? Okay, this is what I'm saying. The total change of energy, of potential voltage around a closed loop is 0. So I gain energy E, I lose energy VR across the resistor. So E minus VR is equal to 0. Why is there the minus sign? Because they have to add up to 0, right? They are equal amounts but in opposite directions. I'm going uphill here, I'm going downhill there. So I'm gaining potential energy in one, I'm losing potential energy in the other. Now VR, you remember, was from Ohm's law, I times R. So what you say is E minus I times R is equal to 0. Energy conservation. First of all, the fact that they add up to 0 tells me the voltage drop across the resistor is equal to the voltage provided by the battery. And second thing it tells me is the current. The current flowing through the resistor is going to be the voltage provided by the battery divided by the resistance. So if I know the voltage of the battery, I know the current flowing in the circuit. If I know the voltage of the battery and the resistance, I know the current flowing through. That's the first principle. The second principle is charge conservation. So imagine I have water flowing through a pipe. It gets to a junction. Some of it goes this way, some of it goes the other way. If I measure the total amount of water in this pipe and add it to the total amount of water in the second pipe, I have to get the total amount of water that came in to begin with. Or think of these individual charges flowing. They either go one way or the other. So if I add up the charge here and here, I will get the charge that came in. How do I write this in terms of current? Well, let's say I have current I1 coming in, and it divides into current I2 and I3. Can anyone tell me how I would write my conservation law for currents? So I1 coming in, I2 and I3 going out. The current going out, I2 plus I3, is equal to the current coming in, I1. So I1 is equal to I2 plus I3. Okay, now you know all of circuit theory. Delta V around a closed loop is 0. Sum of delta V around a closed loop is 0. Every current entering a junction is equal to the total current leaving a junction. These are collectively called Kirchhoff's circuit rules, named after the scientist, the German scientist who came up with them. They are called the previous one, let me just show you, is called the loop rule because it applies to a closed loop. This one is called the junction rule because it applies to a point where current is coming in and going out.